Today's lesson will be focusing on polynomials, but first we need to go over some vocabulary. A monomial is a number or product of numbers and variables with whole number exponents. So essentially, it's something that just has one term, and that one term could be composed of numbers or variables or even multiple variables. An example, and I'm just going to list a few actually, would be like x to the fourth power, or just a number. We could have 12. It could be a combination of numbers and variables, so 4a squared. It could even be two different variables, so we'll put b, or it could just be all variables. So something else that I could put here is x cubed y to the fourth power times z. All of these are monomials because it just has one term, but the stuff that's inside of that term is all being multiplied together. Next, a polynomial. A polynomial is a monomial or a sum or difference of monomials. Each monomial is a term, no variables in the denominators or exponents, no roots or absolute values of variables. All variables have whole number exponents. So I'm just going to write a couple of examples, and then we're going to get to some more vocab here. Like I said in the definition, it could just be one monomial, so 3x to the fourth power, that's just one term, or it could be a sum or difference of multiple terms. So we could do 3x squared minus x cubed. We could do 5x cubed plus 8x squared plus 3x minus 17. You could go as high as the fourth power, fifth power, sixth power, so on and so forth. All that matters is that we have at least one term, and again, that it meets the criteria that was listed in the bullet points. The degree of a monomial is the sum of the exponents of the variables. So keyword here is sum. If there's more than one variable with a power, you need to add them together. I'm going to use, I'll use blue to show this. Okay, so blue is what I'm going to use for the degree. And we're just going to take a look at each of the examples I've already used to talk about the degree. All right. If I'm looking at this monomial right here, I have x to the fourth power. So 4 would be the degree. The next one, I just have a 12. There is no power here. It's just a number. So there is a 0 degree here. Okay, so when it's just a number, the degree is 0. Now for the next one, I have 4a squared b. Technically, this is understood to be b to the first power. So if I want to know what the degree of this monomial is, I actually have to add the exponents. So 2 plus 1, which would be a degree of 3. And for this last one, same thing. The z is understood to be to the first power, so I have 3 plus 4 plus 1, meaning that the degree here would be 8. So that's the degree of one term, or a monomial. Now we have the degree of a polynomial. So when I look at a polynomial, remember it can be one term or it could be multiple terms. Separated by addition or subtraction. If you're trying to determine the degree of a polynomial, then we use the greatest degree. Okay, the greatest degree. So and once again, I'm going to use blue here. Let's look at the next example when we listed out different polynomials. Okay. My first polynomial example was actually a monomial because it just had one term. The degree here would just be 4. For the next one, I need to identify the term that has the highest degree. So I have an x squared or an x cubed. Well, 3 is larger than 2, so this polynomial has a degree of 3. And for the last one, if I compared the x cubed, the x squared, the x, and then the constant, which technically just means that there's 0 x's, or x to the 0 power, the largest one would be the 3, once again. So the degree here is 3. Okay. Last vocab word is leading coefficient. I will be using green to denote this. The leading coefficient is the first term in standard form. So if it's in standard form, that means that it's going from highest to lowest power. Okay? And the first term is just the number that's associated with the highest power. Let's take a look here. In my first polynomial, the highest power was 4. So the leading coefficient is the number in front of my x to the 4th power. So my leading coefficient here is 3. For the second polynomial, the highest power was the 3. So if I wanted to write this in standard form, this would technically be highest to lowest power, so negative x cubed plus 3x squared. The leading coefficient would be the number in front, so technically that is a negative 1 for the leading coefficient. And the last polynomial, it is already written in standard form, so all I have to do is look at the number associated with my x cubed, which is 5. We could also classify polynomials. We classify it based on either the degree or the number of terms. I'm going to use red this time. Okay, so we classify them based on their degree or their number of terms. I'm going to use the example here to go over it. There are 4 terms here, so it would be a polynomial with 4 terms. And this polynomial has a highest degree of 4. And because it has the highest power of 4, let's look at this part of the table now. There's a 4 right here. We would call that a quartic function. You are pretty familiar with some of these terms already. For example, a number, so a degree of 0, we talked about that up here. Remember I had mentioned that if it's a constant, technically it's x to the 0 power being multiplied by it. So just a number which has x to the 0 power, that degree of 0 is a constant. A linear function has x to the 1st power. We just got done with the quadratic chapter, which we knew was x squared. We've heard of cubic functions before, so really what may be new is a quartic function and a quintic function. Anything higher than that, we'll just say a degree of whatever number. Let's take a look at this next example. So example 1, we have to identify the degree of each monomial. Well, the degree here is pretty easy. It's just going to be 3. For example 2, remember we need to add the exponents. So I have 3 plus 2 plus 1. So I have a degree of 6 here. And then example 3, we have 12.4. That's just a number. There is no x term, so technically it's just a degree of 0. Example 4, there's multiple things we're going to do here. We have to rewrite in standard form, identify the leading coefficient, degree, and number of terms, and then we have to name the polynomial function. So we got lots of stuff going on. The first thing that I'm going to do is I'm going to rewrite it in standard form. Standard form, once again, I mentioned it up here, is from highest to lowest power. So my highest power is the x squared. I'm going to put that term first, negative 5x squared. And then that would be an x, so plus 4x, and then plus 3. I'm going to go ahead and write it in standard form over here as well for example 5 while we're at it. Again, we're going to do highest to lowest power. So my highest power is here, the 5. So I have negative 5x squared. Here's the 4, negative 9x to the 4th. There's a 3 over here, so plus 2x cubed. There is no square, but there is an x, so that would come up. And then there is no number that I need to put at the end here. All right, now we need to identify the leading coefficient. So I used to make those green. I'm going to do green once again just to help us identify it. The leading coefficient here is going to be negative 5 and a negative 1. All right, now I'm going to do the degree in blue. The degree is going to be the highest power since we're looking at a polynomial. Here my degree would be 2, and here my degree would be 5. And then last thing is the number of terms, and then the name. So both of those are going to be in red. Let me scooch this over just a little bit. So I want the number of terms, and then we're going to name the polynomial. I have 1, 2, 3 terms. If we look at the table up here, if I have 3 terms, that's called a trinomial. You heard me call it that a lot in the quadratics unit when I had 3 terms. So a trinomial. And then we name it based off of the degree. So we said the degree was 2, making it a quadratic function. All right, let's look at the next one. We have 1, 2, 3, 4 terms. So this is a, if I look at the table, polynomial with 4 terms. And then the degree was 5. So when we go to name it, it would be called a quartic, or excuse me, a quintic function. I looked at the 4. So the degree of 5 is a quintic function. This next section is really similar to what we were doing with complex numbers. We're just adding or subtracting, and we're going to combine like terms. So addition is actually the easiest because when we're adding, all we have to do is keep the signs. This is equivalent to 4a minus 5 plus 3a plus 6. To combine like terms, I'm going to put the a's together. So 4 plus 3 is 7a. And then the whole numbers I would combine. So negative 5 plus 6, that's a positive 1. And that's it. Let's take a look at example 7 now. Now we have subtraction. The only extra step we have here is we need to remember we're subtracting each of these terms. Essentially, you're going to distribute that negative to all 3 terms, making this 3p squared minus 2p plus 3. This all stays the same because it's out front, but everything after the minus changes sign, so minus p squared plus 7p minus 7. And then we combine our like terms. So what we combine is stuff that has the same degree or the same power. I have p squared. So 3 minus 1 is 2p squared. And then I have p's. Negative 2 plus 7, that's a positive 5p. And then I have constants or numbers. 3 minus 7 is minus 4. Please try example 8 and example 9 and then hit play when you're ready to check your answer. The key was to make sure that you distributed the square, and then when you combine like terms, here's what you got as your solutions.